In this very important video, let's learn how to express a triple integral in 6 different ways. In this case, the example will be not trivial because E is a solid bounded by plane z equals 0, plane z equals 8y, and a parabola x squared equals 4 minus y. Let's try to sketch the graph. The graph will be the most important part here. So, z, x, and y. X and y. First, the plane z equals 0, that's the floor, right? So that's x, y plane. Whatever is missing, you know, that's the one will not be changing. So that's my floor. Now z equals y, 8y. In the plane, this one, the vertical plane, draw a line z equals 8y. For example, something like that. Z equals 8y, right? And now it becomes a plane that goes infinitely like so. So let me try. It's pretty hard to draw in 3D, but try your best. Like so. Z equals 8y. Since x is missing, x can be anything, but z and 8 are fixed. And now the most important is x squared equals 4 minus y. So if you imagine x and y, then it's going to be a sad looking parabola concave down, like so. Right? Because it is y equals minus x squared plus 4. Minus 4. No, plus 4. So it's concave down parabola. So, thinking about that, find the point on the positive y, right? This is the positive y. You can actually calculate the exact location of the vertex, but you don't have to. And then, on this xy plane, the floor, you draw a parabola. What kind of shape is that? The parabola will make the floor on z equals 0 plane, and then this blue plane, now we don't need the negative part of it because 0 already fixed that we only go up. The parabola makes it like so, and then there is a plane. The plane is going like so, right? Now the plane is also restricted by the shape of the parabola. So it's going to be like so, going up to z, and so. And this is the 3D picture of the object we're talking about. That's my E. That is my E, a solid bounded by z equals 0, z equals y, 8, and a parabola on the floor, which is xy shape, plane. Here's a nicer looking picture. I just wanted to show you how to draw it, how people actually figure out this picture. The parabola on the floor. And this is z equals 0 and z equals 8y plane. And z equals 0, like so. Now, here are my 6 solutions. As you can see, there will be 6 different integrals. Z goes first, x go first, and y goes first, the order you choose. So you fix the first one and the other 2 alternate. These are the solutions for this problem, so I have them here to make sure I don't mess up and don't lose anything. Let's do it step by step. The first integral we chose to be function f inside, and then dz goes first. So z will be from a function to a function. This is a 3D part all the time for all of these. It's a 3D part. So we need to see the 3D picture, which is here in front of you. I'll make it bigger. A nice looking 3D picture. In 3D picture, z is a height of this 3D solid, right? How does this height is changing from the bigger function, which is on the top, bigger, to a smaller function, which is at the bottom. Smaller. Luckily, we have equations for both. This one is called z equals 8y, and this one is called z equals 0. So it will be from 0 to 8y. So that actually was not that bad. After you're done, the hard part starts. When you finished this step, you're going into 2D picture. And a 2D picture is the one that doesn't have z anymore. In this case, it collapses into xy plane, where z is 0. When z is 0, we are located in a 2D xy plane. That matters because it will change. For example, over here, it will be zy plane. In this case, the parabola is concave down, stops at 0, and this is what we have. Now you choose if you want to do dy first, like in number 1, then y will be from a function to a function. Again, top and the bottom. This is my y, changing from the lower function to the higher function. What is the function at the bottom? That is the function y equals 0. What is the function at the top? That is the function given over here. X squared equals 4 minus y. Solve for y. Y equals 4 minus x squared. So this integral will be from 0 to 4 minus x squared. Again, functions. The last integral must be numbers, must have limits of integration as numbers. dx. There's only one left to do. X is from this number to this number. X is running left to right. What are those numbers? We actually don't know. We need to figure this out. To find these numbers, we need to solve the system of equations to find points of intersection with the parabola and y equals 0. Well, when 0 equals 4 minus x squared, x equals plus and minus 2, and we're using both here. So x is from minus 2 to 2, and this is the answer for number 1. Done. Let's speed up a little bit and see what's happening for the answer number 2. For the answer number 2, it's easier to stick with the same result of dz, f dz from 0 to 8y, and now switch between dx and dy. So you don't have to redo the inner part, that is the same. So now x will be from a function to a function, and the picture is the same. Here is the picture. But now x is going, I will actually redo the picture for you. X is now going from the larger function, which is on the right, to a smaller one, which is on the left. It's always larger minus smaller, right? But what is the larger function? The one on the right is the positive side of the parabola, and the one is on the right is the negative side of the parabola, which can be described as square root. Let's see. From the equation y equals 4 minus x squared, we need to have x equals and x equals. So let's solve for x. And this is why we don't have a unique answer, because x squared equals 4 minus y. X will be plus and minus square root of 4 minus x. So it's going from small to large, right? From small to large, bigger and smaller, which is from minus a square root of 4 minus y to plus a square root of 4 minus y. Now that was dx, right? It's supposed to be in purple. Let me change this to be purple. And this one is also 4 minus y. Now, in green, dy left to do, and dy is now from a number to a number. The bottom one is obviously 0. But what is the top one? That is the vertex, right? How to find this vertex? This vertex can be found either from the formula minus b over 2a or just x equals 0, right? When x is 0, you plug it over here. Y is 4. And that's how you complete example number 2. That's the first couple. Done. Try to do by yourself to make sure you understand what is going on. Let's do number 3. Let's speed up a little bit. Number 3, integral, integral, integral. What did we choose for number 3? It's very random choice, so I want to stick to this notation. F. They chose dx, dy, dz. Okay, so now x will be in 3D. That's the idea. We're going back to the 3D picture. And then we now need to see how x variable is changing in 3D, not in 2D anymore. So let's see. In 3D, look carefully at the picture. In 3D, x is changing from, this is positive side of x, right? So this is 0, and then back to the back, it's negative. From smaller part to larger part, x is still changing from this part in 3D, this part of the parabola, to this part of the parabola, but now it's still coming from the same equation, basically, even though it's from this type of wall to this type of wall. And this equation is x squared equals 4 minus y. So when you solve it in 3D, you will have that x is changing from minus square root, let me put it in red, minus square root of 4 minus y2 plus square root of 4 minus y, 4 dx. Now the hard part, you need to shrink into 2D picture for dy dz plane. That is yz plane. What is yz plane? This is where good imagination will help, but this is this wall over here when x is shrinked to 0. So collapse front and back to 0. Or you can draw it. Draw, and then let's keep z to go up, y to go to the right. Or you can do any other way. You can do y go up and z go to the right. In this case, let's choose y. Y is changing from a function to a function. What do we know about y? There is a line here. We don't need negative, by the way. We know that it's not going to the negative part. It's z equals 8y. This is what we know. And from here, we also know that y reaches its maximum, so it cuts off at this tip. But what is this tip? Here it is. It's the tip of the parabola. So it looks like this, as you can see, up, down, like so, right? So it's going to be a line down. Kind of a triangle, basically. So this tip is at 4. We already solved for that. Yeah, it's basically a line. The parabola part only happens in the wideness left and right. But left and right is controlled by x. X right now is shrinked to 0 because we already used x. So now we're going to 2D. So everything else is just a plane. This is just a plane, like so, which is a triangle. So y is going from the function z over 8. Y is going, in this case, from left to right. Left to right. What is on the left? Y equals z over 8. What is on the right? Y equals 4. y equals 4. Yes, that makes sense. This is the line over here, y equals 4. So it will be from z over 8 to 4 functions. Remember, those are functions. Finally, z is coming from a number to a number. What numbers are these? Z in this picture is height. So from 0 to this tip. What is this tip? We have to find it. We don't know. This is intersection of two functions. Y equals z over 8 and y equals 4. 4 equals z over 8. So z is 32. Z is going up and down from 0 to 32. And we are done with number 3. Number 4, we're going to keep the inside part the same, not to have to calculate the x part again. From minus square root to plus square root. You can fill in detail if you want. I will fill in for you. And now let's switch. We're going to have dz first. So the same picture. You see, we're using the same picture actually all the time. Into the now z is going from the function to a function. Z is going from this function on the left to this function on the right. The function on the left actually is given as 8y. Z equals 8y. We know that. Z. No, z is height. Yeah, sorry about that. Z is going up. In this case, z, what used to be our y, is height. Z is going from z equals to 0 to z equals 8y. From 0 to 8y. And now y is going from left to right, whatever used to be x, left to right. It's run now. Y is changing from 0 to this place, 0, and this place, since it's y equals 4, and in general we remember it is 4, here it is, so it's from 0 to 4. That is my dy. So you see, you actually go faster after you figure out the pattern. 5 and 6, only 2 left, so stay with me. It will be integral f. Now we did not only do one, dy. What is happening if we want to see dy in 3D? And then the third left plane, which now will be dx dz. Okay, let's look at this again. Y is changing from a function to a function. What kind of functions we have here? Let's review again. We have z equals 8y plane. That will be important because now we can say in 3D y is changing from y is my left to right 3D direction. So the smaller one will be this one on the left, which is z over 8. So in 3D, actually y is going from z over 8. On the right, y stops at the line going up. What is the equation of this line? But it's not a line, by the way. It's actually a 3D parabola, looking like so, right? So, what is the function of that? Y equals 4 minus x squared. At any slice, you will have this shape. 4 minus y squared, 4 minus y squared, no matter what z it is, because it's technically speaking plus 0 times the z. So any height I'm choosing, I will still get this parabola. So that's how I know. So it will be till 4 minus x squared. Check, it's y equals. That should match. Now we have two options. Let's do dz. I'm dizzy. I just realized it's a good joke. dz means now we will have a new plane. What kind of plane? dz dx. This one will be more natural to imagine because x will be at the bottom and z will be at the top. So let's see. dz dx. It is this vertical plane, but we don't go negative, right? So what do I see here? Nothing. I don't see anything there. So let's figure out what is happening. dz definitely starts from 0. See? Z is growing from 0. So that is the easy part. 0. Let me put it in blue. 0. Then at the top, I will have to figure out that there is no y. It's not just there is no y here, but the thing is that z is keep going from 0 up, sticking to this tilted shape. And this shape is made up with this parabola. So this shape makes a shadow onto the plane we're looking at. The shadow is concave down parabola, looking like so. This is basically the shadow, as you can imagine, like so. From equations, it's actually a little bit easier to understand. Y equals z over 8 and y equals 4 minus x squared. We need to get rid of y because y creates a three-dimensional object and we are going to the plane that does not have any y. No y. So let's plug one into another one. Any actually is good. It's going to be 4 minus x squared equals z over 8. Boom, no y. This is an object that is located on xy plane. Multiply by 8 and you will have 8 times 4 minus x squared equals z. Well, that's not a nice way to write it down. Z equals that is concave down parabola. If you want to see it, if you want to see it the way you know, it's going to be minus 8x squared plus 32. This is concave down parabola with a vertex over here. And the equation minus 8x squared plus 32. Or you can do factored form with 8, which looks better. So z is going from 0 to this shape, from 0 to this shape. So I will write down from 0 to, which way do you like more? Let's do minus 8x squared. Minus 8x squared plus 32. Finally, x is going from a number to a number. What numbers? I'm talking about these numbers because x here is running from minus 2 to 2. How do we know? We already found it before. That is intersection of this parabola when z is 0, right? Because z is 0 on the x-axis. So 0 equals, that's why it's nice to have a factored form. It's actually easier. X will be plus and minus 2. Minus 2 to 2. And we're done with this integral. Finally, the last one left. It will go a little bit faster because we're done with most of the part here. F dy. Y is from z over 8 to 4 minus x squared. And now we will have dx going first at the same picture. Just like in the previous example, x now is going from the negative side of this parabola to the positive side of this parabola. This time I will write it down for you that we need to solve for x, right? So z equals minus x squared plus 32. Solve for x. X will be, should I show you steps or not? I guess you should do it by yourself, yes. Plus or minus a square root of 4 minus z over 8. How do you do that? Subtract 32, divide by minus 8, take a square root. And you will get those two square roots. So visually it looks like so. X is changing from minus square root 4 minus z over 8 to plus square root of 4 minus z over 8. Like so. Minus square root of 4 minus z over 8 to plus a square root of 4 minus z over 8. Finally, z is going to be easy one. It's going from this point to this point. The lowest point of the floor is 0 for z. The highest point is this vertex. This vertex is when x is 0. When x is 0, z is 32. And we are done. Amazing job. If you stayed awake, now you, I think, can handle all those cases. Basically, you need to have a 3D picture in each case and then 2D picture for each couple. And then you reverse the order of integration for each couple. So imagination matters, as I mentioned before. In Calculus 3, it's very hard to survive without forcing yourself to practice good imagination. Here's the nice looking answers for you. And good luck, because this is not easy, but you're doing good. See you next time.